is no National Electrical Code, or NEC, requirement for a minimum number of circuits per freestanding cubicle. The inspector likely made a mistake or was referring to a local code not applicable to the area. The National Electrical Code only mandates sufficient circuits to meet the load requirements of the equipment in use. According to the National Electrical Code Section 220.4, the minimum circuit requirement for a general-purpose branch circuit is 1 circuit per 120 square feet of floor area. Extra circuits would not be needed if load requirements can be met. For current projects, comply with the National Electrical Code and provide sufficient circuits to meet the cubicle's load requirements. If the customer is not providing power-ready cubicles, engineer drawings to provide power distribution to the cubicles. Consider these points. Firstly, calculate the total load. Determine the total power consumption of all devices and equipment that will be used in the cubicles. This includes computers, monitors, task lighting, and any other electrical devices. Use the nameplate ratings of the equipment to determine their power consumption in amps or watts. Secondly, determine the number of circuits needed. Divide the total load by the voltage of the circuit, typically 120 volts, to determine the total current in amps. Divide the total current by the maximum current carrying capacity of each circuit, typically 15 amps or 20 amps for a general-purpose branch circuit. The result is the minimum number of circuits required to meet the load requirements. Thirdly, consider future expansion. It is always a good idea to provide some extra capacity for future expansion. This can be done by providing more circuits than are currently required or by using larger conductors that can handle more current. Fourthly, comply with local codes. Local codes may have additional requirements for the number of circuits required for cubicles. Be sure to check with the local electrical inspector to ensure compliance. Fifthly, use appropriate wiring methods. The wiring method used to supply power to the cubicles must be appropriate for the environment and the load requirements. Common wiring methods include flexible metal conduit, armored cable, and non-metallic sheath cable. Sixthly, provide overcurrent protection. Each circuit must be protected by an overcurrent device such as a circuit breaker or fuse. The overcurrent device must be sized to protect the conductors from overload in short circuit conditions. Seventhly, ground all equipment. All electrical equipment must be properly grounded to protect against electrical shock. The grounding conductor must be sized according to the National Electrical Code. Eighthly, label all circuits. All circuits must be clearly labeled to identify their purpose and the equipment they serve. This will make it easier to troubleshoot problems and perform maintenance. Ninthly, inspect the installation. A qualified electrical inspector should inspect the installation to ensure compliance with the National Electrical Code and local codes. Tenthly, provide documentation. Provide documentation to the customer that includes a wiring diagram, a list of equipment, and the results of the inspection. This will help the customer maintain the electrical system and make it easier to troubleshoot problems. A general-purpose branch circuit serves multiple outlets for lighting and appliances. A small appliance branch circuit serves receptacles in the kitchen, pantry, dining room, and breakfast room. An individual branch circuit supplies only one appliance. The National Electrical Code specifies minimum requirements for general-purpose receptacle outlets in dwelling units. Firstly, in every kitchen, family room, dining room, living room, parlor, library, den, sunroom, bedroom, recreation room, or similar room or area, receptacle outlet shall be installed so that no point along the floor line in any wall space is more than 6 feet, measured horizontally, from an outlet in that space, including any wall space 2 feet or more in width and the wall space occupied by fixed panels in exterior walls, but excluding sliding panels. Secondly, receptacle outlets are to be installed in accordance with the following. Countertop and work surfaces in kitchens and pantries must have receptacles so that no point along the wall line is more than 24 inches from a receptacle outlet. Peninsular countertop spaces that are 24 inches or wider and have at least 12 inches behind the countertop must have at least one receptacle outlet. Island countertops that are 24 inches or wider and have at least 12 inches behind the countertop must have at least one receptacle outlet. Thirdly, at least one wall receptacle outlet must be installed in bathrooms within 3 feet of the outside edge of each basin. Fourthly, at least one readily accessible receptacle outlet must be installed outdoors at the front and back of every dwelling unit with direct access to grade. Fifthly, at least one receptacle outlet must be installed in each laundry area. Sixthly, at least one receptacle outlet must be installed in hallways of 10 feet or more in length. Seventhly, at least one receptacle outlet must be installed within each attached garage and detached garage with electric power. Eighthly, at least one receptacle outlet must be installed for each unfinished basement space. Ninthly, at least one receptacle outlet must be installed on balconies, decks, and porches that are accessible from inside the dwelling unit. Tenthly, all 125-volt, 15-amp and 20-amp receptacles installed in dwelling units must be tamper-resistant receptacles. The National Electrical Code specifies requirements for dedicated circuits for certain appliances. Dedicated circuits must be provided for the following appliances. Firstly, electric ranges and ovens. Secondly, electric clothes dryers. Thirdly, electric water heaters. Fourthly, dishwashers. Fifthly, refrigerators. Sixthly, freezers. Seventhly, microwave ovens. Eighthly, garbage disposals. Ninthly, washing machines. Tenthly, air conditioners. The National Electrical Code specifies requirements for the number of receptacle outlets that can be connected to a branch circuit. General-purpose branch circuits are usually rated at either 15 amps or 20 amps. The number of receptacle outlets that can be connected to a branch circuit depends on the rating of the circuit and the load that is expected to be connected to each outlet. For general use, the National Electrical Code recommends that a 15-amp branch circuit should not serve more than 8 receptacle outlets, and a 20-amp branch circuit should not serve more than 10 receptacle outlets. These recommendations are based on the assumption that each receptacle outlet will be loaded to its maximum capacity. However, in many cases, the actual load on each receptacle outlet will be less than its maximum capacity. In these cases, it may be possible to connect more receptacle outlets to a branch circuit. The National Electrical Code specifies requirements for the location of ground fault circuit interrupter, or GFCI, protection in dwelling units. GFCI protection is required for all 125-volt, 15-amp and 20-amp receptacles installed in the following locations: bathrooms, garages, outdoors, crawl spaces, unfinished basements, kitchens, laundry areas, wet bar sinks, boathouses, and storage buildings. GFCI protection is also required for all 125-volt, 15-amp and 20-amp receptacles that serve countertop surfaces in kitchens. GFCI protection is provided by a ground fault circuit interrupter, which is a device that detects ground faults and interrupts the flow of electricity to prevent electric shock. Ground fault circuit interrupters are available in 2 types: receptacle type and circuit breaker type. Receptacle type ground fault circuit interrupters are installed in place of standard receptacle outlets. Circuit breaker type ground fault circuit interrupters are installed in a panel board and provide protection for the entire branch circuit. When determining the number of circuits needed for cubicles, consider the type of equipment being used, the load requirements of the equipment, and any applicable codes or regulations. Ensure that the electrical system is safe and reliable and that it meets the needs of the occupants. The National Electrical Code Section 220.4 provides minimum requirements for calculating branch circuit loads. These requirements ensure that the electrical system is designed to safely handle the expected load. Firstly, lighting loads. For dwelling units, a minimum lighting load of 3 watts per square foot is required. For commercial buildings, the lighting load varies depending on the type of occupancy. Secondly, receptacle loads. For dwelling units, a minimum receptacle load of 1.5 volt amps per square foot is required. For commercial buildings, the receptacle load varies depending on the type of occupancy. Thirdly, appliance loads. The load for each appliance must be calculated based on its nameplate rating. Fourthly, motor loads. The load for each motor must be calculated based on its horsepower rating and the motor's efficiency. Fifthly, heating and air conditioning loads. The load for heating and air conditioning equipment must be calculated based on the equipment's nameplate rating and the local climate conditions. The National Electrical Code Section 220.14 provides requirements for calculating the load for general use receptacles. General use receptacles are those that are not specifically intended for a particular appliance or piece of equipment. The load for general use receptacles is calculated based on the volt-amp rating of the receptacle. Firstly, single receptacles. A single receptacle is one that has only one receptacle opening. The load for a single receptacle is calculated at 180 volt-amps. Secondly, duplex receptacles. A duplex receptacle is one that has two receptacle openings. The load for a duplex receptacle is calculated at 180 volt-amps. Thirdly, multi-outlet assemblies. A multi-outlet assembly is a strip of receptacles that are connected together. The load for a multi-outlet assembly is calculated at 180 volt-amps per foot. Fourthly, show windows. The load for show windows is calculated at 200 volt-amps per linear foot. Fifthly, track lighting. The load for track lighting is calculated at 150 volt-amps per foot. The National Electrical Code Section 210.11 provides requirements for the number and type of branch circuits required in dwelling units. Firstly, general-purpose branch circuits. A minimum of 220-amp branch circuits must be provided for general-purpose receptacles and lighting in kitchens, dining rooms, living rooms, and bedrooms. Secondly, small appliance branch circuits. A minimum of 220-amp branch circuits must be provided for small appliances in kitchens, pantries, dining rooms, and breakfast rooms. Thirdly, laundry branch circuit. A minimum of 120-amp branch circuit must be provided for the laundry area. Fourthly, bathroom branch circuit. A minimum of 120-amp branch circuit must be provided for each bathroom. Fifthly, individual branch circuits. Individual branch circuits must be provided for appliances that are rated at 1500 watts or more, such as electric ranges, electric clothes dryers, and electric water heaters. The National Electrical Code Section 210.12 provides requirements for arc fault circuit interrupter, or RFI, protection in dwelling units. RFI protection is required for all 120 volt, 15 amp and 20 amp branch circuits that supply receptacles in the following locations: bedrooms, family rooms, dining rooms, living rooms, parlors, libraries, dens, sunrooms, recreation rooms, closets, hallways, and similar rooms or areas. RFI protection is provided by an arc fault circuit interrupter, which is a device that detects arc faults and interrupts the flow of electricity to prevent fires. Arc faults are dangerous electrical conditions that can occur when insulation on wires becomes damaged or worn, or when electrical connections become loose. Arc fault circuit interrupters are available in two types: circuit breaker type and outlet branch circuit type. Circuit breaker type arc fault circuit interrupters are installed in the panel board and provide protection for the entire branch circuit. Outlet branch circuit type arc fault circuit interrupters are installed at the first outlet on the branch circuit and provide protection for the remainder of the branch circuit. When installing electrical wiring in cubicles, it is important to follow all applicable codes and regulations. This will help to ensure that the electrical system is safe and reliable. Here are some additional tips for installing electrical wiring in cubicles. Firstly, use flexible wiring methods. Flexible wiring methods, such as flexible metal conduit and armored cable, are easier to install in cubicles than rigid wiring methods. Secondly, use modular wiring systems. Modular wiring systems are designed for use in cubicles and other office environments. They are easy to install and reconfigure. Thirdly, use cable management systems. Cable management systems help to keep wires organized and out of the way. Fourthly, label all wires and cables. Labeling wires and cables makes it easier to identify them and troubleshoot problems. Fifthly, test the installation. After the electrical wiring is installed, it should be tested to ensure that it is working properly. By following these tips, electricians can safely and reliably install electrical wiring in cubicles. Electrical codes like the National Electrical Code, or NEC, are updated regularly. Stay informed about the latest revisions to ensure compliance. Changes in technology, safety standards, and industry practices often drive these updates. Subscribe to industry publications and attend training sessions to stay current. Check the effective date of any code to know when it needs to be implemented. Proper grounding is critical for safety and code compliance. Grounding ensures a low impedance path for fault currents, reducing the risk of electrical shock and fire. All metallic parts of the electrical system, including conduit, enclosures, and equipment, must be properly grounded. Use appropriate grounding conductors and connectors, following the National Electrical Code guidelines. Regularly inspect and test the grounding system to ensure its effectiveness. Overcurrent protection devices, such as circuit breakers and fuses, protect electrical circuits from overloads and short circuits. These devices must be properly sized and installed to protect the wiring and equipment. Use the correct type of overcurrent protection device for the application. Circuit breakers are resettable and can be used in most applications, while fuses must be replaced after they blow. Regularly inspect overcurrent protection devices to ensure they are functioning properly. Consider energy efficiency when designing and installing electrical systems. Use energy-efficient lighting, such as LED fixtures, to reduce energy consumption. Install occupancy sensors to turn off lights in unoccupied areas. Use energy-efficient appliances and equipment. Design the electrical system to minimize voltage drop and losses. Implement power monitoring systems to track energy consumption and identify areas for improvement. Electrical safety is everyone's responsibility. Follow safe work practices when working on electrical systems. Wear appropriate personal protective equipment, such as gloves and safety glasses. De-energize circuits before working on them. Use lockout-tagout procedures to prevent accidental energization. Never work on electrical systems when wet or damp. Report any electrical hazards to the appropriate authorities. Understanding and adhering to electrical codes ensures safety, prevents fires, and protects property. It also ensures compliance with legal requirements and avoids costly penalties. Invest in training and education to stay up to date on electrical codes and best practices. Consult with qualified electrical professionals for complex installations and projects. By prioritizing electrical safety and code compliance, you can create a safe and reliable electrical system for your home or business.